Hey folks, how are we doing tonight? This is a little video that I thought I would make just to kind of give you a background on polynomial long division. And actually through this background, what I hope to show you is that polynomial long division is very similar to long division as you might have seen in the past, okay? And so what I'm going to do is I'm actually going to give you a little warm-up and kind of a little primer for this long division technique based on the long division we already know. And then what I'll do is I'll go ahead and work through a couple examples of polynomial long division using various cases, okay? And hopefully through this you'll gain a little bit of a sense of how you might also engage in doing some polynomial long division on your own, okay? So just again, this video is to kind of help you out, so I really recommend throughout the video, if need be, kind of wind back, take a look at things, and really try to make the most of it. All right, so what I'm going to do is I'm going to show you something that I did on my calculator here. So on my calculator, you can see that I did this formula, okay, 6123 divided by 5. And you can see right here my answer, 1,224 and 6/10, okay? So this is essentially taking 5 and saying, how many times can I get 5 into 6,123? Well, I can get it in there 1,224 times, and this dot implies that there is a remainder. And we might remember when we do division, we also always get the quotient, in this case 1224, and the remainder, 0.6. All right, but what does that 0.6 look like when we do long division? Well, I'll show you right now. Okay, so what I'm going to do is I'll show you what this looks like, okay? So what we get is we get 5 into 6,123, okay? And if you guys remember long division, what we know is we're going to start with the 6, and we're going to ask ourselves, well, how many times can I get 5 into 6? And I can get 5 into 6 a total of 1 time. Okay, so I'd write my 1 over here to represent how many times 5 goes into 6. And I go ahead and I, in a sense, take the 1 and multiply by 5 and write my answer underneath, right? So this is exactly representing the number of times I can get 5 into 6. Okay, and then what I do is I go ahead and I'm going to subtract and bring down that 1 from the subtraction. Remember, and then the 1 comes down. Okay, so essentially what I've done here is I've said, well, how many times can I get 1 into the thousandths place, right? This represents one of the places or place values of this number 6123, okay? So, and this represents the number of thousands in the answer, right? Because remember, we know our answer is 224, all right, with a little remainder. So now that I bring the 11 down, I continue, right? How many times can I get 5 into 11? All right, and if I was to kind of do that division, if we kind of think about off to the side, 11 over 5, well, look, I can get 11 over 5. I can get that in 2 whole times, right? This is 2 with a remainder of 1. Okay, and I'll write that 1 there to represent the remainder, and we'll see how to represent that in just a minute. Okay, so what I'll do is I'll write my 2 there, right? And by the way, a similar thing happened with the 6. If we do this 6 off to the side, if we do 6 divided by 5, we can see that it would be 1 with a remainder of 1, right? Okay, so here I go. I take my 2 times my 5, and that shows me the biggest multiple of 5 that I can get into 11. As usual, I subtract, and now the 2 comes down, okay? And if I continue this in a similar manner, right, what I get is I can do my 12 into my 2, or rather my 5 into my 12, right? And I'm getting ahead of myself in a sense, right? Because I get, goes in 2 whole times, this time with a remainder of 2, right? And I can see that remainder when I do, again, the subtraction. And let's not forget to put our 2 up here. Okay, and lastly, now I bring down the 3, and I'm going to do a similar thing, right? How many times can I get 5 into 23? Well, I can get it in there 4 times with a remainder of 3. Okay, and so again, I take my 4 whole times, I put it up here. I take my 4 times my 5, I get 20, and that leaves me with 3. And now there's nothing to bring down, and that tells me that I'm done. All right, now this is kind of a really broken down version of how we would do this with regular long division with numbers in arithmetic. So we have this sense of taking the current biggest term and dividing it, or in a sense leading term, dividing it by the what we call divisor, taking the exact whole number of times we can get in and bringing it up, taking that whole number of times and multiplying it by the divisor, subtracting out, and kind of starting to bring things down as we go. Okay? So it's kind of like, I know, somewhat of a methodical process, and so I totally understand, and I've kind of really dragged it out, but the point is to really see how the parallels play out. Now remember, I'll bring this answer back in. We got the 0.6. Where does the 0.6 come from? Well, look, our final remainder is 3. So actually what we have is we have a remainder of, right, 3. But now, if I was going to wrap this up, remember, my last step would essentially, in the idea of this, be to take 3 and divide that 3 by 5, right? And what's 3 divided by 5? That's 0.6, okay? So we get the 1224, representing the whole number of times that 5 goes in, plus the 0.6 to represent the 3 out of 5, that is the remainder. Okay, now what I'm trying to get at is that long division with polynomials is, again, a very similar process, okay? And to show you that, what I'm going to do is I'm going to launch into a little example here that will show you where I'm coming from, okay? And to do that, here's what I'm going to show you. Now I'm going to show you what happens if I do the x minus 2, okay, into this guy right here, x cubed minus 4x squared plus 2x plus 5. Now, what we see here is this is a very similar process, right? So let's take a look at some parallels. Here, right, I took my 6, I said, how many times can 6 go into 5? 1 time. Here what I'm going to do is I'm going to say, I'm going to start and I'm going to look at, this is going to be my key term, okay? So I'm going to take what's called my leading term of the divisor, or rather the dividend, that's what we call this part, and I'm going to divide it by the leading term of the divisor. So I'm going to say, well, how many times can I get x into x cubed? Okay, and by using the laws of exponents, we know that that's a total of x squared times, right? So what I'm going to do is I'm going to take my x squared and I'm going to put it above the x squareds. One of the things you've got to be careful with polynomial long division is to really be methodical with how you organize the answer. What I'm going to do now, similarly, what did I do here? Well, I took my 1, I multiplied it by the divisor, I put it underneath in the appropriate place, right? Because this represented 5,000, right? Because this was 1,000, because this is 1,224, right? So this is 1,000 times 5. This is x squared times x. So now I write it here, and I write an x cubed, and then I take my x squared, and in this case, I'm going to multiply it by -2, because it's not just an x here. It's an x minus 2, okay? So it's a 2x squared, okay? And what that's going to let me do is I'm now going to subtract this all out. And what you're going to notice is off the bat, the x cubes are going to cancel out. And that is a sign that we're doing the right thing, all right? Every time we take a step in the polynomial long division, something needs to cancel out, okay? So what that means is that now I'm going to do, the reason I showed you this kind of example first is because this is one of the most common areas where people kind of get stuck here. So what I'm going to do is I have negative 4x squared minus negative 2x squared. So it's negative 4 minus negative 2, right? Just like I take 6 and I subtract out the 5. Here I'm taking negative 4 and I'm subtracting out the negative 2, and this becomes like adding 2x squared, right? So what I'm right is becomes a negative 2x squared because it's negative 4 minus negative 2. And in this case, I actually bring down the entire thing. Now, it doesn't matter that you don't really need to bring down the entire thing because remember, just like here, I'm not dividing. I don't really care about this stuff at this step in the game. I'm only caring about that one thing that's coming down. I like to do it here because I just find it's more organized, and some people might do it differently, and they're welcome to do that. All right, so now I continue my procedure here. I've got the leading term of my new guy divided by the leading term, and now I got to ask myself, okay, well, how many times does x go into 2x squared? And again, using my kind of properties of exponents, I get negative 2x. So what I'll do is, again, I'll put that above my x's. And again, the idea is we really want to be methodical. We really want to make sure we're staying organized here. That is going to really prevent a lot of slip-ups when it comes to this stuff. And then I take, and now, again, noticing that I'm going to get, if you don't get the canceling out, if these things are not the same, then you got to go back and take a look at what you did to get this. So I do the negative, and then what I do, this is nice, look at this. This becomes a plus 2x, because again, it's a minus 2x. Uh-oh, mistake, right? Don't let that happen to you. See, sometimes you forget to do the multiplication. So it's a negative 2 times a 2, that's a positive 4, okay? So it's a negative 2x, so it's a positive 4x. Okay, fortunately I was able to catch myself there. Phew. Okay, and now what I do is I subtract it again. So negative 2 minus negative 2, 0, cancel out. Okay, here we got to be careful. 2 minus 4, okay, that's going to be negative 2x, and then the 5 comes down. Notice, there is nothing here, right? I'm not subtracting out anything. So you could see it as essentially an invisible 0 here, right? Because in this case, I'm only subtracting some x squareds and some x's. I'm not subtracting anything without x's or any like just straight up numbers. So there should be no impact here because nothing is being subtracted from the 5. All right, and now my last step is finally leading term over leading term. So I get negative 2x over x. The x's cancel out, and that gives me negative 2. Wonderful. And I take the negative 2, I bring it up here, and then again, I'm going to multiply it by everything here. So I go negative 2x plus, okay, be careful here, this is not easy, 4, okay, because it's negative 2 times negative 2. We get that final cancellation, and 5, I like to do it like this, 5 minus 4 is 1. Okay, so this is what we get. Our answer is x squared minus 2x minus 2 plus 1 over x minus 2. Notice here how we did the remainder over the divisor. Here we do a similar thing, except our divisor is not a number, it's an expression, x minus 2. So when I get my number, I just bring it up and I do it like this. Here's another way to write the notation. So here's how this would be written out. I would say x cubed minus 4x squared plus 2x plus 5 divided by x minus 2 is equal to x squared minus 2x minus 2, okay, plus 1 over x minus 2. That would be how you'd write this out. Again, so this is me showing the actual division, and sometimes people just do the traditional the traditional division sign like this. Sometimes people represent, so they'll do this divided by this, usually with parentheses so that you don't get that kind of confused. That's just another way to write it, okay? So this is how we do that. All right, so go ahead, if you need to, go ahead, kind of wind back through that, watch how I did that step by step, and then in a moment, I'm going to show you another little example of how I'm going to do this one, okay? Very, very similar idea. All right, I'm going to move on to another little problem here, and I'm going to show you another little case of how we do it, okay? And this is going to be a very similar kind of problem. So here's what we're going to do. We're going to do the problem 2x cubed plus 4x squared minus 5 over x plus 3. Okay? Now, here's what I'm going to do for this one. I'm going to set up my long division. So I've got x plus 3. Okay? Write that there, like my little house. And then 2x cubed plus 4x squared minus 5. All right, so let's go back and take a look. How did I start here? Okay, here I started with the leading term, or the thing with the biggest power of x, and I divided it by that. So let's go ahead and take a look. Okay, so we'll take our leading term and our leading term, and we're going to divide them by one another, right? So I'm going to say, well, what times x equals 2x cubed? Well, I need the 2. Right? Because 2 times 1 is 2, right? We think of this as like a 1x. And then to get the x to an x cubed, I need it to be an x squared. So I need 2 to get the 2, and x squared, okay, to get the x squared. Now, notice one thing that's missing here. Okay, we don't have anything with an x in it. So here's what I'm going to recommend you do. I'm going to go ahead and recommend, while you can, that if you have a 0 coefficient, you go ahead and write that in. So I'm going to flip that -5 into a 0, and then I'll put the -5 in the end, okay? This is the same thing, because to have no x's is essentially the same as saying to add 0x, right? But here's the thing. I want to stay organized, and I promise you, the idea of putting in the 0 coefficients when you have those 0 coefficients, I'm promising you, will help you when we investigate other methods, and it will mean the difference between right and wrong when we do the other methods, okay? So again, 2x squared times x equals 2x cubed. So that's why this is here. Then I'm going to multiply through 2x cubed. So again, seeing that these are the same, extremely important, plus 6x squared, okay? Now I'll go ahead and do my subtraction. So these will cancel, and now I've got to do 4x squared minus 6x squared. That's -2x squared. Okay? We'll bring down that 0x, and we'll bring down the -5. Again, bringing down both is really up to you. We can see we're not going to have to use the -5, but I'm just someone who likes to bring everything down. And again, maybe different teachers will have different approaches there. All right, now I'm going to do the same thing. Well, what times x equals -2x squared? Again, I need a -2 to get the -2, and then I need an x because x times x equals x squared. Okay, so that's where that's coming from. And again, you can verify this. Another way to verify this is to go, okay, well, I have -2x squared, and I divide by x, and what do I get? -2x, right? So that's another way of knowing that that's what needs to go here, okay? So again, I multiply everything through, and I get -2x squared minus 6x. And that is the reason why I use those placeholders of 0. If I didn't use that, I'd be like, oh man, well, I had this -5 that I brought down. Where is the x going to go? Okay, so that's why it's really, really important to have those placeholders. Okay, so again, I do my subtraction, cancel, and then I do 0 minus -6 becomes a +6, okay? And the -5 comes down. Last step, what times x is 6x? Well, that is a +6. And then again, I come through 6x plus 18, okay? When I multiply through, again, I subtract, the x's cancel, and I have 5 minus +18 for a -23. Okay, so my answer is 2, let's bring it down, 2x squared minus 2x plus 6 all over, whoa, not all over anything, 2x squared minus 2x plus 6 plus, well, is it a plus or a minus? You could look at it as two ways. I like to think about it as a plus because it's a remainder. We're always adding it on. So it would be -23, my remainder, over x plus 3. Or, another way to look at it, 2x squared minus 2x plus 6 minus 23 over x plus 3. That's another way to look at it. Though these two things are entirely the same. Adding a negative being the same as subtracting a positive. All right, and so again, I know it's kind of a very procedural, step-by-step thing, but again, we're going the leading term, the biggest power of x, over the leading term, the biggest power of x, writing the answer here, multiplying through, canceling, bringing down, and so on and so on. And if you think about it, it's again very similar, right? This was the leading term. This was the leading term, right? So leading term over leading term with a 1. And here, the fact that we're getting stuff left over is similar in nature to what we're having left over there. Okay? So go ahead and if need be, kind of wind it back. Okay, take a look. And then I'm going to go ahead and I'm going to do one more example to help us really solidify what's going on from a kind of step-by-step standpoint there. Okay, I'm going to show you one more example, okay? And this is an example that's definitely a more difficult, a little bit more rigorous example, okay? And I think that in general, you might be starting to say, wow, there's really a lot to this division stuff with a long division. And you know, you're not necessarily wrong, okay? And so I hope that maybe in part this will motivate why we might need to think about another method, and that will come into play eventually, okay? Okay, so here's what I've got. I've now got 2x cubed minus 4x, okay, plus 7x squared plus 7 all over x squared plus 2x minus 1, okay? That's the problem that I need to now do, and I'm inspecting it. Let's see if there's anything we notice. Well, the first thing I notice is, not in standard form. So the first thing I'll do is I'm going to convert this into standard form. Remember, the order of the actual terms does not matter so long as the signs are appropriately converted, right? So I can move the 7x over, the 7x squared over, as long as I remember that it's a positive 7x squared, whereas this is a minus 4x. Okay, so I'll rearrange that. So again, being in standard form first, important. All right, nice. Now I'm in standard form. Outstanding. Haha. Okay, now I'm going to go ahead and set up my long division. So here I go. Okay, here's my divisor. Okay, here's my dividend. And let's take a look. Okay, again, any zero coefficients to account for? No. That's why I did not put any zeros in there. Okay, you'd obviously want to think about that if that was applicable. And I don't see that, so that's a good sign. I'm good to go. Okay, so now this one's a little bit trickier, and that's all right. I'm going to start again. Leading term over leading term. Now here the leading term is x squared. And remember, leading term equals, look for the largest exponent. Okay, whatever has the largest exponent at that time. Well, with the divisor, the divisor is never being messed with. So the divisor, the leading term, is always going to be constant. And as we've seen, right, as we percolate out, okay, in the dividend, the leading term power is always dropping. So first, for ours, it was x cubed, then it was x squared, and we keep going until there's nothing more to bring down. Okay, so here we're going to take leading term, and we're going to say, well, what times x cubed is x squared? And we better do a little bit of investigation. So I take my 2x cubed, and I divide by my x squared. And again, laws of exponents, what I end up getting is 2x, right? And if you think about it, 2, remember this is a 1, 2 times 1 is 2, x times x squared is x cubed. So here I go. I write my 2x, and notice being very careful to put it over the 4x, and now I multiply through. So we see the 2x cubed, as we should, to cancel. All right, now be careful. We got to really hit everything. Plus 4x squared. Okay, and be careful with your signs. Minus 2x. Okay, and I'll do my subtraction. So as usual, biggest terms cancel. And that's one of the nice things. We beefed this guy up. We made it bigger. We made it a higher power. But the process is still the same. Just like with long division, right? With numbers. If I turn it from a 5 to a 10, if I turn it from a 10 to a 100, or etc., if I beef up the number of places in the divisor, it's not going to make dividing any different, okay? Sorry for any shakiness there. I got a little excited. Now I'm going to go ahead and continue this anyway. So 7 minus 4, that gives me a 3x squared. Negative 4, be careful, negative 4 minus negative 2, that's going to be negative 2x. Again, that being one of the places where people kind of get stuck. And that, again, the signs is where those answers really start to percolate out. And it's unfortunate when the mistakes made early on, because then if I had said, let's say I did negative 6 because I forgot the division, or the subtraction rather, then the next thing I'm going to be is wrong and wrong and wrong and wrong. So we just got to be really careful, and that's why I always follow that principle of rewriting every step. Okay, now again, leading term. So what times 1x squared is 3x squared? Well, the x squareds are the same, so it doesn't have anything to do with the x squareds. It's just going to be 3. And in this case, it's a positive 3. And I come through 3x squared, okay, plus 6x minus 3. Okay, and I bring it down again. Those cancel out right away, okay, as they should. Negative 2 minus 6, giving me negative 8x. 7 minus negative 3, that's going to become an addition, giving me a plus 10. Now, note, can I bring down any more? No, there is nothing more I can bring down. And here's how I know. I have an x squared. This is an x, okay? If the power or exponent rather of the biggest term, the leading term, is lower than the exponent of the leading term here, you're done. There's nothing more you can do, and you leave it like that, okay? And notice, here's the degree. The degree is 1. Here the degree is 2. Here the degree is 3. So the degree of the quotient is always equal to the degree of the dividend minus the degree of the divisor. Okay, that's always true. The degree of the quotient, 1, is always, or I should say rather, and this happens to be true, right? The degree of the quotient, degree of the remainder, we got a similar thing, right? But in this case, there's not really any more we can do, but the degree of the quotient is always equal to the degree minus that degree. Let's take a look at what we got on the other side. Here we got a similar thing, right? The degree of the quotient, 2, equals the degree of this, 3, minus the degree of this, 1. And that's because the degree, we remember, is determined by the biggest power. And the biggest power is determined essentially right away. The biggest power in the quotient is always going to be the biggest power of this divided by the biggest power of that, okay? So let's go ahead and state our remainder, minus, and there's a lot of ways you can do this. I'm going to make it a plus because this is a little bit trickier here. So what I'm going to do is negative 8x plus 10 over, what's our divisor? X squared plus 2x minus 1. And that is our answer with a little bit of a remainder in there, and that's okay. Okay, so definitely not the easiest process. It's definitely got some challenges to it. So here's what I'm going to do. I'm going to do what I call a little you try. I'm going to give you 2 little problems here, okay? Here's my problems for you. You try them, and then we'll talk about them. All right, and I'm going to try to give you a little bit of different kinds of flavors here. But maybe what I'll do for now is I'm going to stick to just a couple ones where we only have a degree 1 in our divisor, and then maybe in a subsequent video or exercise, I'll kind of turn up the heat. Okay, so here's our first problem. Okay, we have r squared plus 14r plus 38 divided by r plus 8. Okay, there's 1. And then what I have is x squared plus 5x plus 3 over x plus 6. Okay, so go ahead. I want you to try these. And then in a moment, I'm going to give you the step-by-step worked through solution. All right, here we go. Here's the step-by-step. So our first one, r plus 8. And we do r squared. Again, no exponents of 0, so we're good to go. Okay? And we'll start leading term over leading term. That is r. Okay? Double check that. Make sure you got just that r. Multiply through r squared plus 8r. Do the subtraction, immediate cancel, 14 minus 8, giving me 6. Okay, now I do my next. What times r is 6r? And remember, it's good to identify those leading terms. It is 6. Bring the 6 down, 6r plus 6 times 8. Hopefully you know this. 8, 16, 24, 32, 40, 48. And this is something you could use a calculator for potentially as well, but this is something we could also do in our head. And that gives me, cancel, 38 minus 48 is negative 10. Okay, so we come up, we write negative 10 over r plus 8, because remember, in the end, technically, we are dividing this by r plus 8 as well, except we're not going to get any real action made on that. Okay, so that's our first one. Next one, we'll go ahead and do x plus 6 into x squared plus 5x plus 3. And a similar thing, leading term over leading term. We'll get x, and then when we come through, we'll get x squared plus 6x. Okay, so we do our subtraction. We got canceling. Okay, we got these cancel, and then 5 minus 6 gives me negative 1x. Okay, leading term over leading term. Well, what times x is negative x? Negative 1. Okay, we come back through again. Subtract. These cancel. 3 minus negative 6 give me a positive 9. I'm done at this point. Nothing more to bring down. Dividing doesn't give me really any actionable stuff. So I come over, write my 9 over x plus 6, and that's it. All right, folks, so there's definitely a lot going on here, okay? There's a lot to think about. There's a lot to process, okay? This is not easy by any means, but it is something that we can do and we can be successful at, all right? I'm going to walk you through one quick one more because we've seen remainders, but I want you to know they don't always have a remainder. So here's going to be one that should not have a remainder. Ready? So I'm going to show you 12 x cubed minus 11x squared plus 9x plus 18 over, okay, not bad, 4x plus 3. And the idea exactly the same as we did before. The only thing that might make it tough is that 4. And let's see what happens. So here we go. 4x plus 3. Okay, again, make sure you do the setup. Okay, so here's what I challenge you to do. Pause it for a second. Try to work through the problem. See if you can do it. And then in a second, I'll go through. All right, let's try our hand at this. Ready? So, what times 4x, remember, get that leading term identified, is 12x cubed. I need 3 to make the 12. I need x squared to make the x cubed. Okay, so I come through, I do my 12x cubed plus 9x squared, and I subtract. So again, these cancel. 11 minus positive 9. Okay, 11 minus positive 9, that's negative 20x squared plus 9x plus 18. Okay, now I repeat it again. So what times 4 is negative 20? What times x is x squared? Okay, and then I come down again, negative 20x squared. Okay, plus or minus, this is a minus, minus 15x, right? And it's full of tricks. Unfortunately, that's what's full of tricks. So we may need to have a better way of doing this one, right? All right, so those go. And remembering to really be precise here. And then 9:15, yay, my birthday. 9 minus negative 15 is 9 plus 15, 24x. Okay, and last step is, let's go ahead and do leading term over leading term. That's going to give me 6, because 6 times 4 is 24, right? And we've got that x coming down. So we come through 24x. And look at this, 6 times 3 gives me 18. And we can see that this is going to cancel. And 18 minus 18, this is going to cancel, leaving us with a remainder of 0. And in that case, you can just go ahead and box in, and we are done, okay? And what that shows me is that this thing is what we call a factor. This, rather, is a factor of this, because when you divide by your 12, and when I say this is a factor of this, I mean to say 4x plus 3 is a factor of 12x cubed minus 11x squared plus 9x plus 18, because when we divide, we get a remainder of 0. Okay, here's the thing. As I've stated, this is not easy. There's a lot of procedure. If you mess up any of the subtraction, it's really tough. And the thing is this. I think it's fair to say, we struggle with subtraction. We struggle with division. 2 hard operations. I'm not judging. I totally agree. These are not easy operations. But what you might have noticed by now is one of the most important things we're actually working with is we're mostly just working with the coefficients, right? The 12, the 11, the 9, the 8, the 20, etc. That's the only thing that's the real big hard part of it, right? Figuring out the x's to get the x cubes, the x squareds, the x, that wasn't as tough, if you might think about it, as, well, what times 4 is 12? What times 5, what times 4 is 20, negative 20? What times 4 is 24? That's not as easy. So what we're going to have to think about is there a better way to do this? And what if I told you that only by actually using our maybe 2 favorite operations, addition along with multiplication, we could actually solve it in a fraction of the time? That's going to be our next method of dividing. It doesn't always work. It's not going to work on all of them, okay? But it actually will be a really cool method for solving in a GIF, okay? So again, I really hope that you enjoyed this video. I hope that you found it informational. Just, keep those questions coming. My idea is to really kind of expose you to these ideas and give you a little bit of valuable practice. There obviously are some cases that were not covered fully in this video. For example, I only showed you one particular example where we have a division by x squared. Now, long division will be great for that. Not all the methods will be perfect. There's also a similar method involving the box that we could do, okay, that I might discuss. But this is just hopefully getting you your kind of feet wet in the ideas of long division. And folks, just keep working at it. It's not easy, but you got to believe in yourself, because here's the thing. I know that you can do it. All right? Keep staying positive. Keep coming up with those questions. Keep working at it, and you have what it takes to be successful. All right? I hope you enjoyed the video. Again, have a wonderful night, and remember, don't forget to love math.